Find the value of the gradient of y is equal to 3x minus 2 times 2x plus 3 over x at x is equal to minus 1. So we got here a quadratic quotient of a quadratic over a linear function. So the first step would be to expand the brackets here. Right, so we've got 3 times 2x plus 3 minus 2 times 2x plus 3. Some people prefer to use the full method. And then over x, so I'm going to get 3x times 2x, which gives me 6x squared. 3x times 3 gives me plus 9x. Minus 2 times 2x gives me minus 4x. And minus 2 plus 3 gives me minus 6 divided by x. So we're going to collect together like terms. So we're going to get 6x squared. We've got 9x minus 4x, which gives me 5x minus 6 over, now it's all over x, but I'm now going to split it up, the common denominator. So I'm now going to write 6x squared over x, 5x over x, and 6 minus 6 over x. Although they will have the same denominator, I'm going to split them up. The reason for doing so is now I can do 6x squared divided by x, which gives me 6x, 5x over x, which gives me 5, and then minus 6x, and now 6 over x means x to the minus 1. And now I'm in the process of differentiating. So remember, I've got to do quite a bit of preparation before I can actually differentiate. So if y is equal to kx to the n, dy by dx is nkx to the n minus 1. So I'm now going to differentiate each of these terms individually. So differentiating this, 6x from before is just be 6. If I differentiate a constant, I get 0. You don't necessarily have to write that in. And then bring that power down in front. We're going to get plus 6x, and reducing it by 1 minus 2. So that comes to 6 plus 6 over x squared, applying the rules of indices to that. At x is equal to minus 1, this becomes, dy by dx becomes 6 over 6 divided by minus 1 all squared, which gives me 6 plus 6, which gives me 12. If we look at the graph of that, this is the green one is the graph of this function here. Here is x is equal to minus 1. Here is the tangent drawn at that particular point, and at that particular point the gradient of the tangent is 12. You could probably just about work it out from the graph if you wanted to. Okay, so the gradient of the tangent at x is equal to minus 1 is 12. So what you've got to always remember when you're differentiating, when you're finding the gradient function, is the geometrical meaning of it. Okay, so this has been a video to show you how to differentiate the quotient of a quadratic over a linear function. I hope you've understood, and I thank you very much for watching.